Let's talk about exclusive OR. Exclusive OR, or XOR as it's commonly called, is derived from a combination of AND, OR, and NOT gates. So in a sense, you can think of exclusive OR as a circuit. XOR can be thought of as one or the other, but not both. This gate produces a 1 if and only if one of the two input values is 1. If both input values are 1, the gate produces a 0. So let's take a look at Logisim, a piece of software that allows us to create circuits. And we'll derive the XOR gate. In this presentation, we will derive the exclusive OR, or XOR gate, using some of the existing gates we've already looked at. Now the software tool I'm using here is Logisim, something we'll use in class. So this video will also serve as an introduction to Logisim. Now to build a circuit in Logisim, we first begin by going up to the toolbar and clicking the icon that looks like an arrowhead. This will allow us to add things to our circuit. Now first, we want to add some gates. Now there's a couple ways to do that. You'll notice up here on the toolbar there are a few of the gates we've seen before: NOT, AND, and OR. And also down here on the left, we do see a folder that says gates. And if I expand that, we see a bunch of different gates that we can add to our circuit. I'm going to start with two NOT gates. Now, to do this, we click on the gate we want, in this case NOT gate, and then I move my mouse over. Now I'm not dragging at this point, I'm just moving my mouse, and once I find a location that I want to drop it, I just click, and it puts the gate onto my diagram. Now I need a second NOT gate here, so I'm going to do the same thing. I'm going to click it, and I'm just going to move my mouse, again, not dragging, and I'll put it right there. Now to derive the exclusive OR gates, I also need a couple of AND gates. So I'm going to go over here, click on and I'm going to do it right about there. Now you'll notice here with AND there are 5 blue dots. Those are the 5 inputs to the gate. We only need 2 inputs. Logisim is flexible and allows you to customize that. So I'm just going to change this by going over here to the lower left, and choosing the number of inputs to be 2. These properties or attributes are things that you can change about the gate. Now I'm going to do the same thing, so I'm going to grab another AND gate, and I'll place it, that's good. And again, it has 5 inputs, so I'm going to change that to 2. We also need an OR gate. So here I'm going to go up to the toolbar. I'm going to do this slightly differently. I'm going to go up to the toolbar, click it, and again I move my mouse to where I want it to go, and I'll put it right there. Just like the AND gate, the OR gate has 5 inputs by default. So I go over here to the lower left, and I change that number of inputs to be 2. Now I'm ready to begin connecting these gates together. The first thing I'm going to need to add are some input pins. These simulate the inputs that would come into this larger circuit. Up here on the toolbar, we see 2 different toolbar icons that say Add Pin. The first here with the rectangle are for input. So I click that. I'm going to drop it right about there. And I'm going to add another one right about there. Now what I want to do is use these as inputs to this larger circuit. So I have to connect the pin to this first gate. Now here I click on the little dot and I drag over to the other little dot on the NOT gate. This connects these 2 items. Now I want to connect the NOT gates to the AND gates. Now what I'm going to do is I'm going to move these AND gates back a little. I think they're a little too far separated. So I'm going to highlight them just move them back. And I'll highlight this and move it back as well. Okay, so again, I do the same procedure. I click and I drag until I hit the connection point. And I'll do the same thing here. Now for the other two inputs, the one here and the one here, I need to do something slightly different. Here, I'm going to start on the AND gate and drag. And when I get to about, let's say here, I'm going to stop by still holding the mouse key down. And I'm just going to change direction. Now what I've done here is connect the AND gate to this input line. And I need to do basically the reverse for this one. I drag over. When I get to this point, I'm going to go up and connect there. You'll notice a circle forms here and here, indicating a junction. Both of the AND gates now have two inputs, and I need to connect the outputs of these to this OR gate. So again, I click and I drag, and here I'm going to make a little sort of a different looking connection. There we go. And here we're going to have an output coming out of the OR gate. Here is where I need this other pin, this output pin, the circle with a green circle inside it. I'm going to drop that right there, and I connect the two together. Now right now, you see that all of these pins, both the two input and the one output, have 0 in them. You can change that, and we're about to do that. Up here on the toolbar, we see this little hand icon. I'm going to click that. That's going to allow me to click on these pins and change their values. And you'll notice as I change it from 0 to 1 and vice versa, different lines here, different wires if you will, change color. If I make that a 1, you'll notice that the output is now a 1, which makes sense because exclusive OR 1 XOR 0 is in fact 1. Now if I make the second pin a 1 also, you'll notice that the output is now 0, as it should be. The wires here in bright green indicate that a 1 is flowing over those wires. The wires here in more of a forest green indicate a 0. So here if I change that to 0, you'll notice that the colors of some of the wires change. This helps you to track the logic that's going on here. Another thing that helps you to track the logic, under the project menu, there is this menu option that says Analyze Circuit. Now, this does a variety of different things, but one thing it can do is here. Under the Table tab, you see what amounts to a truth table for this circuit. And we see that it matches the truth table for the exclusive OR. We get a 1 in the output column when we have 1 and only 1 of the inputs having a 1. This concludes our introduction to Logisim and our example of deriving an XOR circuit.